Hypothesis testing. Hypothesis testing is a logical and empirical procedure whereby hypotheses are formally set up and then subjected to empirical test. The research question to the hypothesis testing has two forms. The null hypothesis, H0, which maintains that there is no difference between two groups or conditions. Alternative hypothesis, often represented by H1 or HA, which maintains that there is a difference between the two groups or conditions. So basically in research, when they're conducting research, they will be testing a hypothesis. So hypothesis that there is no difference, and alternative that there is a difference. Difference can be greater or equal to or not equal to, depending on the parameters which have been tested. So H1 can take two forms depending on the nature of the research question. Either can be directional or non-directional. So when we mean directional, we say it's greater or less than. Non-directional, it's not equal to. We don't have any direction that was given. Can either be greater or less. Directional anticipates the direction of the difference, whilst the non-directional anticipates that a difference is expected. So that's what we mean. Here we are saying it's greater or less than. But directional is either, we are saying it's greater or we are saying it's less than. So let's illustrate in this type of hypothesis test. So when it's greater, you say your HA or the alternative hypothesis, you say it's greater than. We are testing that greater than a certain value. So this is a right-tailed test. Then a left-tailed test is less than. We are testing that a certain mean is less than a certain value on this side. Then when it's a two-tailed test, it's non-directional. We are saying it's either greater or less than. So if H1 is directional, we use one-tailed test, which can either be this one or this one-tailed test. And this non-directional, we use two-tailed test. So it depends when I'm doing the question, how the question is structured, so that you'll be able to identify whether it's a one-tailed test or a two-tailed test. Decision errors. There are two types of decision error. The first type is called the type 1 error, occurs when the researcher rejects a null hypothesis when it is true. So type 1 error, you reject H0 when in fact it is true. So this is the type 1 error, H0 when true. This one when true. Reject H0 when true. The probability of committing type 1 error is called the significance level, also known as alpha, represented by this symbol, often expressed as a percentage or a decimal. So when they say we are testing a significant level of alpha 0.05, that's what it means. So in most questions it will be represented as a alpha. So it can be a percentage or a decimal. So type 2 error occurs when the researcher fails to reject H0 when it is false. So now type 2 error is you accept now H0 when in fact it is not true. So this type of error, you accept H0 when it's false. When it is false. So this question sometimes they come in multiple choice questions. So you must be able to know type 1 error is accepting H0 when it is false. Type 2 error accepting H0 when it is false. And type 1 error is rejecting H0 when it is true. So the probability of not committing type 2 error is called the power of the test. However, the probability of committing the error is called beta. But in most of the questions that we do, we don't come across this beta symbol. Mainly they use alpha. So you are just safe by knowing the alpha. So let's move on. Decision rules. If the test statistic falls within the region of acceptance, now hypothesis is not rejected. So it means, like, let's say we are testing, let's say that the second value is greater than. So if your test statistics falls in this region, it means we accept. So your test statistic will be a certain value here, a set value. But when it falls in this rejection region, it means you reject. So if the test statistics within the region of acceptance, H0 is not rejected, region of acceptance is verified so that the chance of making a type 1 error is equal to the significant level. And say significant level. So when we make that decision, we specify at what significant level. If it's alpha, it's equal to 5%. We should specify it on our conclusion. The set of values outside the region of acceptance is called the rejection region. So the rejection region we usually shaded, and the acceptance region is usually unshaded. So these are things to note. If the test statistic falls within the rejection, H0 is rejected. That's what it falls here in the rejection region is rejected. In such cases, we say that the hypothesis has been rejected at alpha level of significance. So you should specify at what. So usually when alpha is not specified in a question or an article, you assume that alpha is close to 5%. So 5% is normally the standard that we use, unless it is you are asked on a certain particular question to use a certain alpha. But when it's not stated, use 5%. Remember this, please. Let me repeat it. When alpha is not stated, use 5%. Because that is the standard which they normally use. The set of values outside the region of acceptance is called the rejection region. If the test status falls within the rejection region, we've done cover this. The critical value separates the critical region from the non-critical region. So in this case, this is our critical value, which is a Z value, in case we are dealing with the normal distribution. So this is the critical value CV. It separates the rejection region from the acceptance region. The location of CV depends on the inequality sign of the H1, now alternative hypothesis. So for the H0, remember it's always that there is no difference. So you're assuming that mu is equal to mu. For H1, you're assuming it can be mu can be greater than a certain mu, or a mu can be less than a certain mu, or you can say mu they are not equal. So depending, so if it's greater, that's when you use this right one. When it's less, it means our rejection region will be at this side. If it's not equal to, it means we include both sides. The rejection region will be like we have demonstrated in the previous slide, like that. Depending on the distribution of the test value, we will use different tables to find the CV, which is the critical value. So you usually use the normal. You can also use the t-test. You can also use the chi-square test, and so on. So, but as for now, we have covered the normal distribution. In the following chapters, we will cover the t-test and the chi-square test. They are also used in the hypothesis testing. 5 steps in statistical hypothesis testing. So remember, these steps, you should always include them in when you're solving hypothesis testing problems. So at first you should follow, you should refer to this like steps, but as you do more questions, these steps will naturally become part of you as you are solving them. So first step is to state the hypothesis. So hypothesis has got two forms, H1, H0 and H1. So you specify your hypothesis, then you define the significant level. Let's say alpha is equal to 5%, that's your significant level at which you are testing. Then define the critical values, so you define CV, then calculate the test statistics, which means test statistics you can use the Z-score from the normal distribution, or you can use the t-test, the chi-square test, like this is just an example when I used it. Then reach a conclusion and conclude the results. Reach a decision and conclude the result. So the decision is to accept or reject. Then you conclude. So these are the 5 steps. State the hypothesis, define the significance level, define the critical values, calculate the test statistic, reach a decision, and conclude the results. So let's give an example to illustrate this. A researcher thinks that if expectant mothers use vitamins, the birth weight of babies will increase. The average birth weight of the population is 8.6 pounds. State the now hypothesis and alternative hypothesis in case. So this question only requires you to state. So now when you are stating this, you should find the keyword. A researcher thinks that if expectant mothers use vitamins, the birth weight of the babies will increase. So increase, it means greater. So it means for your H0, you're expecting your mean to be equal. Mean 1 is equal to 8.6, no difference. So for the alternative H1, you're expecting your mean to be greater than 8.6. So this is your now because the keyword is increase. So this is how you do it. So now hypothesis testing common phrases. So these ones will help you to when you're solving. So when you hear something like is greater than, is above, is higher than, is longer than, is bigger than, is increased, you use greater for your H1. Is less than, below, lower, shorter, smaller, decreased, reduced, you use less than. If it's equal to, is same as, has not changed, is the same as, you use equal. If not equal to, is different from, has changed from, is not the same, you use. But these ones, they don't usually okay because the one we cover is one-tail test, which can either be greater or equal, or a two-tail test. Two-tail test and one-tail test, one-tail test. So these are common phrases that can help you to remember. But these 3 are the most commonly used in the exam questions. So let's do a more full-fledged example. It has been reported that the average credit card debt for college seniors is 3,262. The student senate at a large university feels that their seniors have a debt much less than this. So the keyword is much less. Much less. So it means use less than this. So it conducts a study of 50 randomly selected seniors and finds that the average debt is this one. And the population standard deviation is this one. So let's conduct a test based on type 1 error of So your alpha is 0.05. So your keyword here is this one. So the first step is state your hypothesis. So H naught is equals to mu is equals to 3262. And remember the keyword was less than, so alternative hypothesis mu is equals to is less than to 3263. So you define your significant level. It's already stated 0.05 your alpha, then it's a left one tail test because it's less than, so we are looking at this region, the one tail test. Then the third step is define your critical values. So remember, you are testing at 5% significant level. So it means you go to your tables and look for 0.05. Because remember, 5%, 0.05 is what we are testing at. So we are looking for. So it means this area under the graph, this one, should be equal to 0.05. So as you can see that this graph shows that the values you get here will be equal to this region. So you just go to your graph and look for 0.05. So as you can see here, 0.05, the closest one is 0.505 and 0.405. So now using linear interpolation, you get this third value. So remember it's 1.64, 1.64, 65. So it's somewhere between these two. So if you use linear interpolation, you can determine this one. So once you get your critical value, it means you are testing to be like this. You are testing, this is your rejection region. So this one will be minus 1.645. So this is your CV, critical value. So now the test statistic, if it falls in this area, we accept it falls in this area, we reject. So let's move on to step 4. So this is the formula you use. So remember, if you read your question carefully, it says it has been reported that the average. So we are talking of average. Yeah, average. So when you're talking of average, you now know it's sampling distribution of means. Average credit card debt for students this is an average. The student senate at a large university feels that their seniors have a debt much less than this, so it conducts a study of 50 randomly selected seniors and finds that the average. So you can see, debt is 2,995, and the population standard deviation is. So now you know that you are using sampling distribution of mean, where this one is your mean, this one is your standard deviation, this one is your population. So we now use sampling distribution of mean. That's why you're using Z. Remember what we've covered. Your mean debt minus your population, whatever. That's why you're using this formula. So now you should be careful when you're doing hypothesis testing. You must be able to determine whether it's just a simple normal distribution, or is it a normal distribution? Is it a sampling distribution of mean, or is it a t-test, or is it a chi-square? Should be know when it's a t-test, you must know which type, because there are 3 types of t-test. We'll cover this one in the. So we have determined that this is the same distribution of mean, so we use this formula. That's why we put these figures, then you're supposed to get this value. So now this is your. So remember, when you are drawing your rejection region, you have to determine that this is minus 145. So this is your rejection region. So since this test is greater, it means it will be somewhere here. So it means it falls in the rejection region. So reach a decision and conclusion, step 5. So status is in the rejection region, and this is the critical value. So reject H0 at alpha 0.05 and conclude that invested students have credit card debt that is less than the reported average. So things do not. Significance level and confidence level are closely related, but not necessarily the same. So in most exam questions that I've seen, they don't use confidence interval, they use significance level, which means they mainly use alpha. But just to be safe, I'm just gonna cover this one, but it's not like if you don't. So for a two-sided hypothesis with a threshold of alpha is confidence is equivalent to a confidence level of 1 minus. So we are saying, when you're saying that is if 95%, so for a two-tailed test, you're saying when alpha is equal to 5%, it means our confidence level will be equal to, for a two-sided hypothesis. So two-tailed test, so it means it becomes 1 minus 5%, which is equals to 95%. This is for a two-sided. So basically what it means is we are saying the 95 is the middle part. So we are saying this is the rejection area. So we'll be saying this acceptance region where we are confident that the result is 95% accurate. So this one will be 2.5%. 2.5% for this to make it 100%. So we're saying for a two-sided hypothesis with a threshold of alpha is equivalent to a confidence level of 1 minus alpha. That is, if alpha is 5%, then confidence level is. So if you are given 95% confidence level, it means your alpha is 0.05. However, for a one-sided hypothesis with threshold of alpha, the equivalent alpha is equivalent to a confidence level of 1 minus 2 alpha. So for a one-sided test, which means if alpha is close to, let's say use 5% again, it means for a one-sided, your confidence level will be equal to 1 minus 2 alpha, which is equal to 1 minus 10%. So it means it becomes 90%. So this is something that you should know just in case they don't give you alpha and they give you confidence level. Then you say, what's that? So now that's how you do it. So however, once I did, I've already covered that one. So this one's something that you should know just to safeguard yourself so that you don't get confused in the exams. Practice questions shall be covered in the exams section. So in this one, we do a comprehensive practice questions so that we nail this thing. So thank you for watching. If you have any questions concerning this section or you need any further information, call us on 074 920 9697. Thank you and have a great day.